For this lesson, we're going to introduce the idea of factoring, and in particular as it relates to quadratic relations. We're actually not going to focus on quadratic relations in this lesson, but the skills of factoring, and in particular common factors, is going to be an integral part of any attempt at factoring. Common factors are actually always your first preference or your first choice when you're trying to factor something. So it's really important to develop this skill and to develop it well. To start, let's take a look at a type of factoring that you should be familiar with, but you might need a bit of a refresher on, which is to factor the number 40. Now, when we talk about factors, what do we mean by factoring? A product of prime factors. So product means it's going to be a multiplication, and prime factors, that means that in the case of a number, that means it's a prime number. It's a number that can't be divided by anything other than itself or 1. So for example, 1 is a prime number, 2 is a prime number, 3 is a prime number. 4 is not a prime number because 4 is actually 2 times 2. And then 5 is a prime number. 6, well, that's 2 times 3. It's not a prime number. So what we're trying to do is reduce this, the number 40 in this case, we're trying to reduce this down to a series of multiplications, a product of numbers that can't be reduced any further. Now, if you are able to see this, you might be able to just list off the product of prime factors for 40. But if you need to, don't be shy about doing some extra work. Take a look at the number 40 and just ask yourself, well, what do I multiply together to get 40? And don't worry if you have to do multiple steps. So for example, you might realize that 40 is actually the same as, well, that's 2 times 20. Okay, that's fine, but 20 is actually 2 times 10. So there's the 20. Oh, but hold on a second. 10 is actually 2 times 5. And now I get down to 2, 2, 2, and 5. So that is there is my product of prime factors. 2 times 2 times 2 times 5 is equal to 40. Now I'm just going to point out here I did use multiplication signs. Only do that when you're dealing just with numbers. Another way you could have done this, and maybe I should, now that I've done that and I was all ready to excuse myself, why don't we write it this way? Times 5. And the reason we want to avoid actual x's, multiplication signs for product, is that we're using variables, and quite often the favorite variable of mathematicians seems to be the letter x, certainly in high school, and so using x's, there's the potential for confusion here. Now something else I want to point out is 2 times 20 becoming 2 times 2 times 10 and so on. That's not the only way we could have done this. We could have actually, maybe you would have seen this a different way. Maybe you would have seen this as, well, hold on, 40 is actually equal to 4 times 10. But 4 can be broken up. 4 is the same as 2 times 2. And 10 is the same as 2 times 5. And you can see very quickly, I still end up with 2 times 2 times 2 times 5. So there are a number of ways that you can do this and end up with the correct result. So next thing to take a look at is what are the, well, when I factor, what does it mean to factor x cubed y squared? Is there anything I can do with that? And what I mean is, in this case, I want to actually represent it as the product. What are the factors of x cubed and y squared? So maybe take a look at these. This is a little bit odd, but if you just remember your definitions for exponents, well, what is x cubed? X cubed means take x and multiply it by itself 3 times. So it's x times x times x. Y squared is y times y. So this is x times x times x times y times y. Now we would never write something out this way. The reason why this is useful, you're going to see this a little bit later in the lesson, is once we can break things down into their individual factors, then we can actually start to get into this idea of factoring. So you're going to see that happen a little bit later. For the term 24x squared, we start with the number 24. Well, the number 24, when I look at that, I think of the product, that's 4 times 6, but 4 is actually 2 times 2, and 6 is actually 2 times 3. So I end up with 2 times. So now I have to be extra careful about the notation I use. Here I use dots for multiplication, but you really want to avoid using dots for multiplication when you have numbers because they might look like decimal points. You want to avoid using x's when you're doing multiplication when there's variables involved because they might look like the variable x. So now I'm really forced into using my brackets. 2 times 2 times 2 times 3. And then the product for x squared as individual factors would be x times x. Again, we're only doing this. This is going to be for informational purposes that we'll do this a little bit later. Okay. So how can we do this? We've got some options. The first option we're going to explore is actually to do this using a visual model. So using algebra tiles. And the way we do this is we actually want to what we do is we take our expression and we form an area, and then the sides of that area are going to be factors. This is the opposite process to what we started with before with algebra tiles. With algebra tiles, introducing them previously, we started with the sides and we used the sides to form an area. Now we're going to show that you can reverse that process. When you do this, be aware, just like I did in my examples here, for example with the number 40, if you see the number 40 as 4 times 10, you're not necessarily done. It's true that 4 and 10 are factors, but they are not the prime factors. So when you are doing work like this, just try to keep in mind the fact that you might have to reduce those factors further, and you keep repeating the process. And when you're working with algae tiles, one of the things you can do to try to reduce your chances of having to repeat the process some more is make your shape as square as possible as opposed to long, thin shapes. So when you're putting something together with your algae tiles, so if this is the area, try to make your area squarish as opposed to having your area be some big, long, thin area. Sometimes that might be the only option that you have available, but I just want you to try to keep that in mind. You want to make it more square and less long and thin. All right, so let's do an example using algae tiles. So I've been asked to factor 3x squared plus 2x. So 3x squared, now I have to line these up. There's 3 of them, so really my only options are to line them up horizontally like this, or I could line them up vertically, but based on my screen layout, horizontally seems to be the way to go. And now 2x. Well, if I tried to put positive 2x like this, I don't end up making a rectangle at all, so that's not an option. I don't think my garbage can is going to work there. And so now my positive 2x is the only place I could do this. Even though I just told you to try to make something rectangular, you can see I immediately get defeated on this one because it's actually not an option. This is the only shape I have, which is relatively long and thin. And now I take a look at the sides. So what is this side? This is a long side. That's an x, and that's an x, and that's an x, and that's a 1 and a 1. So this one is 3x on that side plus 2, and then down this side I have an x. So the answer to this one is I've got a common factor. Normally what we put in front is going to be the smaller of the terms that we pull out here. So normally we think of the x being the common factor, and then what's left over is 3x plus 2. If you need to, you can always reverse this using the distributive property or using FOIL, depending on the product that you make. So x multiplied into 3x, that gives me 3x squared. X multiplied into positive 2 gives me positive 2x. So that's a way you can check your work, make sure that it makes sense. Let's take a look at another example with algae tiles, and then we'll move on to some actual written algebra. 2x squared plus 4x. So 2x squared plus 4x. I could write 2x squared here, and I'm going to do that. I'm going to start off doing this the way that I suggested before, or the way I was forced into doing it on the previous example. So there's 2x squared plus 4x. So if I did this, I would factor it. But this is going to be one of those examples where if I do this kind of long, thin model, where there's another more square model, I actually end up doing extra work. So what is that other model I'm talking about? So let's take those away. And instead, how else could I make my 4x? Well, I could make a rectangular shape that way, but that's only 2 x's. But if I bring down 2 more, there I have my 2x squared plus 4x. And now this one, that's an x and that's an x, which means 2x along that side. That's an x, that's a 1, that's a 1. And so this one is going to be x plus 2. So again, here we've got a single term, a monomial. Normally that's what we'll factor out, or that's what we'll put in front. And then that will be x plus 2. And you could verify this. 2x times x is 2x squared. 2x times positive 2 is positive 4x. And so now on to algebraic options. If we take a look at what we've done before, what we were really doing, what we were pulling out when we did that factoring was something known as the greatest common factor. And we'll quite often do the short form of that, GCF. So we're looking for the greatest common factor of the coefficients and the greatest common factor of the variables. And we're actually, generally we want to do those two things separately because we treat coefficients and variables separately. Coefficients, I mean those are the numbers that are multiplying the variables, or constants, which means a number that doesn't have a variable. Okay, so factor 8x cubed minus 6x squared y squared plus 4x squared y. So to do this, first thing I'm going to do is I'm going to look at coefficients. So that's 8, 6, and 4. I'm not really troubled by the positive or by the subtraction and the addition here. I'm just going to look at the raw numbers. So take a look at the numbers 8, 6, and 4. What is the greatest common factor, meaning what is the biggest number that divides into all of these? This is where the example I did at the very beginning of the lesson starts to help out. What about the number 8? Let's just look at the number 8 on its own. Well, what is 8 as a representation of prime factors? Well, 8 is actually 2 times 2 times 2. What is 6? 6 is 2 times 3. And 4 is 2 times 2. And now that I have these, what I can do is my greatest common factor is equal to, it's the factors that actually are in common with all of these. So the first thing I notice is I've got a 2 and a 2 and a 2. So I write a 2 here, and I can't use those 2's anymore. Now I take a look again. I've got a 2 and a 3. Okay, because even though I've got 2's in the 8 and the 4, I don't have a 2 here. So this is it. That's my greatest common factor. So between these, my greatest common factor is 2. And this is also the reason why we looked at the when we were factoring variables into their representation of primes. So x cubed, x squared, y squared, x squared, y. So what is x cubed? That's x times x times x. What is x squared, y squared? That's x times x times y times y. And what is x squared y? That's x times x times y. So my greatest common factor is equal to, I see an x, an x, and an x. So I'm going to cross those out, and I'm going to put an x here. I see an x and an x and an x in each. So I cross those out, and I put an x here. I see a y and a y, but no y here. So that's it. Because the y's aren't going to contribute. There's no more x's, nothing else in common. So x times x is equal to x squared. So what do I do? Now I could do this in one step. So my greatest common factor overall, so that means I really should have added an extra line for this. So that means that overall my greatest common factor is 2x squared. I can, with practice, you can pull this out, you can factor this out in one shot, but it might be a good idea to start. Let's do it in two pieces. So the first thing I'm going to do is take out my common factor of 2, which is my coefficients. So the way that I do that is essentially what I'm doing is I'm saying, well, what do I multiply by 2 to get 8? Another way to think of that is, what is 8 divided by 2? Well, that's equal to 4. 4x cubed. And take a look at that. What is 2 multiplied by 4x cubed? 8x cubed. This sign, because we're taking out a positive number, positive 2 times a negative, so that stays the same. And what do I multiply 2 by to get 6? 3. X squared y squared plus, what do I multiply 2 by to get this 4? That's times 2. X squared y. And now that I've done that, I'll leave that 2 out. And now let's take out my common factor of x squared. So I'm taking an x squared out of an x cubed. And that's really like saying, what is x cubed divided by x squared? Well, that's x times x times x over x times x. That divides out, doesn't cancel out, it divides out. Each one of these becomes 1, and that leaves me 1 over 1, 1 over 1 times x. So all that's going to be left here, the 4 stays, and x squared multiplied by x. X squared times x would give me x cubed. I've got minus 3, and what happens when I take x squared y squared and I divide by x squared? The x squareds are going to divide out, and that's just going to leave me y squared. And then finally, I've still got my plus 2, and I've got x squared y. When I factor out the x squared, all that's left behind is a y. And once again, I would encourage you to reverse this process in your mind or off to the side as rough work. 2x squared times 4x is 2 times 4 is 8. 8, which is what we want. X squared times x is x cubed, so 8x cubed. This entire process is reversible. So an extra line for the final answer, all in one color, 2x squared, 4x minus 3y squared plus 2y. So that's an example of factoring something algebraically. This is not a quadratic equation. We're just doing factoring algebraically in a very generic sense right now. We will be applying this to our quadratics very soon in the next lesson. Another type of factoring that can be done is called factoring by grouping. And factoring by grouping is important because sometimes when we are factoring, we don't end up with something that's common everywhere, but what we can sometimes do is we can make small groups of things that are common. So for example, my first group, if I take a look, before I even do that, I've got AC and BC and AD and BD. You can see I've got the letters A, B, C, D here, but here I've got A and C, the first and the third. Here I've got B and C, the second and the third. So not everybody, here's A and D. So C is common between these first two. A is common between these first and third terms. B is common between the second and last term. D is common here. So I've got all of these pairings of common terms, but there's not a single term that's common everywhere. So the way that I do this is I'm going to start off by taking a look at AC plus BC. And how you group these, normally you just group these by convenience. These are the first two and they have something in common, but sometimes you might have to rearrange things. Try to rearrange first so you get your groupings together next to each other. So what's common between AC and BC? That's the letter C. And what happens when I divide AC divided by C? That's just going to leave behind an A. Plus, what is BC divided by C? That's just going to leave behind a B. The next group I'm going to do is this one, AD plus BD. Well, what's common here? The D's are common. So I put the D, and what happens when I take AD divided by D? That gives me A. And what is BD divided by D? That gives me B. Now, factoring by grouping is something we try. It's not always going to work. Now, it was chosen in this example. It is actually going to work in this example. So we end up with that is equal to, I take out my common factor of C, A plus B, plus my common factor of D. Be careful, I don't want my D's to look too much like A's. D, and that's going to be A plus B. And if you're feeling pretty sharp about your algebra right now, you might notice, well, hold on a second. I've got this term and this term, but they actually have something in common. They have this thing in the brackets. But how do we deal with that? Now, eventually you want to get yourself to the point where you're comfortable with that and you're going to just factor that on its own. But what I'm going to do for now is I'm going to say so I've used A, B, C, D. I'm just going to say X. Let X equal A plus B. So by doing that, I end up with C, but instead of A plus B, I'm going to write that as C times X plus D. And instead of A plus B, I'm going to write dx. But now the x's, well, those are common. It's much clearer this way now that we don't have the clutter of the brackets there. So now I'm going to actually factor out the x. And what's left behind? Cx divided by x is simply c. Positive dx divided by x is just positive d. And one last step. But what is x? This x is the same as a plus b. And so now I come all the way back around. Instead of x, I put back in a plus b. And I keep my c plus d. So this, using factoring by grouping, was reduced to this. And again, we looked at this in a previous lesson. You could expand this out, a plus b in brackets times c plus d in brackets, and you could confirm that that is in fact ac plus bc plus ad plus bd. If the terms don't come out in the exact same order, don't worry about that too much. Just make sure you rearrange things and they will be the same. And I believe that is it. Then we've gone on to our assigned work.